So again, nice to see you. And my name is Giulio Salvioni. I'm an audio journalist from Italy, and thank you for your time.
Okay, great. Okay.
The first question is about BBC sound design facilities. Could you tell us something about this kind of mythological creature of the audio history? So which type of skills were employed, how big was that facilities, and some information about this.
Well, I think certainly it's Derek who'll answer that, if Derek's got any sound yet.
I've got sound. I'm trying to battle with the microphone. But, yeah.
He is there, but is a little low on volume.
Very quiet.
Very quiet, yeah.
Audio settings.
I think I know a bit about it, Julia, but Derek.
Better?
Oh, yeah. Much better, Derek.
Okay.
Good. Good. Yeah.
Over to you, Derek, then.
Right. Well, I missed the first bit of the audio. What was I being asked?
Yeah, basically just about the BBC facilities and how the mythological sound was created. I think that's right, Julia, is it not?
Yes, absolutely.
Mythological. I wouldn't describe it as mythological. Yes, I guess there's quite a bit of mythology around it. I think, in many ways it's very simple. The BBC wanted to design speakers for use in studio control rooms to monitor what was going on in the studio, so they needed them as accurate as possible. And over the years, they tried all sorts of commercial loudspeakers with greater or less success. That was back in the 1930s, 1940s, and eventually decided they need to design their own. It's that simple. And they went through a number of designs. The first one, LSU 10, which was a great big monstrosity with a 18-inch drive unit, coaxial drive unit. The LS51, the LS31, there were a whole succession as they refined their own designs. And the biggest step, I suppose, and the one that we were most involved with, was the change from paper cones to plastic cones, specifically Bextreme. And that was, again, the result of the drive units they were using at the time, which was a combination of Goodman's and Plessey, just weren't consistent enough to give them consistent results from control room to control room. The point being, of course, that when you've got 50, 100 studios, you want to do a recording in one studio and play it back in another one and hear exactly the same thing. That's the whole concept of monitoring. And so it was decided that they needed to investigate drive units and making them more consistent. And then they decided to vacuum form plastics. And during the time of this investigation, I think they tested, close to 300 different plastics, and various ones are described in the reports. But Bextreme is the one they settled on. Not that it was ideal, but it was most consistent. It was easy to vacuum form, very easy. And with the now famous PVC plastic coatings, was at that point certainly a big step forward in terms of accuracy and consistency, which was the object. So that's the point at which I was involved with it more, because my father was in BBC research at the time. He was basically joined as a mechanic, but to the acoustic section. But obviously loudspeakers are primarily a mechanical device. So he was very soon involved in building the vacuum former and a lot of the practicalities of magnets and chassis and tooling and such like that. So gradually he was drawn in more and more to it. The LS55 was obviously the first major speaker that used the plastic cones. It was the follow-on from the LS51, which was a 15-inch paper cone driver, and it was discovered that the bass response of the smaller cabinet with the extreme cone was pretty much as good as the LS51. Now, I know in one of your questions, it's been pointed out that the LS55 suffered from a lack of power handling, and was a moderately fragile loudspeaker. And I think that's a result of the fact that that was the first attempt by the BBC of actual drive unit design from the ground up. Obviously, they've been using Goodman's and Plessey units, have been designing drivers units for many, many years. And to be honest, were probably more aware of the power handling considerations than were BBC Research at the time. So while the LS55 was hailed as an excellent sounding loudspeaker, it was at a point of monitoring where more and more sound level was being required. You have pop studios and things like that. So particularly at the low frequency end, program material was containing much more high level, low frequency information, and requirements were more and more for high levels. So it was seen as somewhat unreliable, which was a shame because it certainly was a very, very high quality loudspeaker. To jump forward, I suppose, sticking with the LS55, is that when we came to do a redesign on it for Graham Audio, we stuck very closely to the cabinet design and the drive unit layout and such like that, and the fundamentals of what made it a good loudspeaker. But of course, in the intervening sort of 40 plus years, big advances have been made in power handling, quality of materials. So we were able to increase that reliability and power handling. I think in the original report, it was stated that the loudspeaker could handle a program input of 25 watts. I mean, we've run the 555 with 200 watts with no danger. So that was the extent of the increase in material reliability that's happened over those years. But we've stuck to the fundamentals of the design in terms of frequency response, and the type of units, and the cabinet as well, which plays a big part in the quality of the loudspeaker, obviously.
Let me ask you something. When you redesign the loudspeaker nowadays, you can rely on computer-aided analysis. What was the procedure of the testing at the time when they were first developed? So, for example, you talk about many hundreds of different plastic to tested at the time of the development of the cones. But how did this testing was conducted?
Simply is the answer to that. Obviously, although they didn't have computers, they had probably amongst the best test equipment and listening facilities in the world. So it took a lot longer. I mean, the main thing that computer optimization has helped us with is speed as much as anything else. And in the course of these designs, the BBC designed a lot of equipment for the first time to do, for example, they describe as chopped tone tests, which we would use Melissa and waterfall diagrams for. But they did it sort of longhand, I suppose you could describe it as. They did it with literally a tone generator, which would chop tone into short intervals of 5-10 milliseconds, depending on the frequency. And then that will be examined spectroscopically. And a lot of this equipment they designed themselves. One particular piece, which I used to have designs for, which no longer, is their distortion measuring equipment, which was a tracking filter. Again, people like B&K designed tracking filters like 30 years later, but this was literally built valve designed from the ground up. And there's a there's a diagram in the LS55 report showing the output of this device down to, I think, the 7th harmonic or something like that. So the engineers that were available to the BBC at the time were really clever, and they had the facilities and the finance at their disposal to investigate, initially for the first time, many of these factors, which later on people picked up, and then in the computer age were able to simplify and streamline. But they broke a lot of the initial ground in these designs. One of the questions I get asked, and it's implied in one of yours, is, how were these things financed? And it wasn't looked at like that at all. You had, I think, the acoustics department was, 12 engineers, and basically their salaries were paid and all the equipment was there, and they were given a project and they just carried on with the project until it was finished. There was no concept of how much does this cost. There was, in terms of, for example, with cabinet design and cone design, that they realised that it was much easier to produce some of these things than had been previously the case. So, from a point of view of, we've got to make hundreds of these things to go in studios, yes, there was a cost. But in terms of development, cost really wasn't relevant to them, because it was not a commercial exercise.
So, Derek, much the same as at Graham Audio, cost is
very
not
much,
a problem.
Yes. I'll tell my back manager that. Yeah.
But as for Graham Audio, how do you think that the sound of the classic BBC designs could be interesting for younger audiophiles? Because it's something that is rooted in the past.
Well, is accuracy. Accuracy can't be rooted in the past. That must be a constant.
Yeah.
I think Derek will probably add to this more than me because he's had much more experience. But over the years, it appears that most loudspeakers come up with a unique selling point, and they didn't necessarily keep to just accuracy of, as Derek said, one speaker listening in one room, you'll listen to the speaker in another room, it will be exactly the same. So people were enhancing the treble, enhancing the bass. It's neutrality that we've been looking for, which is what I perceive the BBC loudspeakers as. So I would hope that most people, if they're looking for the best way of examining the recording and their audio equipment, because the speakers are very searching on that, they would look to our speakers as opposed to any other speaker which enhances the sound, so to speak. So it's neutrality is what I would hope for. I think Derek might be able to add to that.
I think one of the problems, you referred to young people, one of the problems in this is the way recordings are done.
Yeah.
Now with the BBC, obviously they, again, they use microphones which had a very flat response. They use well-treated acoustic environments for both recording and monitoring. Now that's true a great deal today, but Paul referred to unique selling points, and that applies in recording as well. So you'll get a lot of music that's produced today, which, well, for want of a better phrase, has the frequency response and other things deliberately skewed or altered to produce a certain effect.
Yeah.
And that's fine, but you're not hearing something which is natural. I know one of the companies that took a lot of the Spendor BC1s was WDR in Germany, great big huge broadcast company. And we went over there, the first sort of few that they had, and they had one of their big music studios, they had them in. And we were talking to the engineer, and he was terribly excited. And his phrase was, for the first time, I've been able to tell how far the violin is from the microphone. And that was his, sort of thing, that suddenly he had a real window into the real sound as it was in the studio. But of course, if you're producing music which is primarily electronic, it's never existed in the first place in reality.
Yeah.
So how do you know? And that comes back to the way we approach things. I mean, one of the ways the BBC did, and I still do, is that the human voice covers the vast majority of the audio band, and our brains are designed to be incredibly perceptive and analyze to a fine detail people's voices. So the BBC, and I've got still got a recording of various people, including the father and others, recorded in the BBC's anechoic chamber at Kingswood. And really, the accuracy of voice, in my opinion, is the fundamental building block in a loudspeaker. You can then go out higher frequency, lower frequency, that's fine. But unless you get the central fundamentals right of accurate voice reproduction, then you've lost before you start almost. You know, you're then trying to play catch up the whole time. But of course, if you've got the vast majority of commercial music, which never existed in reality, how do you judge that? How do you judge whether you're reproducing it accurately?
So also the idea of what's reality is somehow shifting.
That's right. Yeah. But of course, the trouble is that if you know, particularly the younger generation who tend not to go to classical concerts, for example, they don't know what things like that sound like. And sometimes on some of these forums, they say, "Oh, you know, you've got to listen to live music," but their concept of live music is an amplified concert, which of course is not live music, not in my book anyway.
Yes.
So you're already one step from reality before you start assessing something. And you know, when you go around exhibitions like Munich and such, most people are playing, for want of a better word, pop music or some strange music, which maybe deliberately no one can actually tell is being reproduced accurately, because it never existed in the real world. And that's a very difficult thing to solve, and you can't solve it because people got to listen to our speakers, and they're used to hearing maybe something at home for years, and your brain gets attuned to a certain style of reproduction. And you listen to something different, and your brain automatically refers it to what you're used to. You know, so you know, if you've got a loudspeaker at home and it's got incredibly high treble, you'll get used to it. You go in to listen to one of ours, and I think it's very dull. Well, no, it's not. You know, it's what you're used to. So these are very hard questions, and it's sort of education, which might sound a bit sort of high-handed, but you often, to get people to listen to reality, real instruments or real voices, and sit down and really absorb really what they're hearing is a difficult job. And most people can't be bothered, to be honest. I mean, personally, when I don't like listening to other people's loudspeakers, I really don't do it as a rule, because I know where I'm aiming and what we've made. And listening to other people's approach to it only confuses me, you know, especially at my advanced age, more and more. But, you know, I just find I know what I can do, and I know what I'm comfortable doing.
Okay.
And there's no real point in trying to push the boundaries of that, because I'll just make mistakes, really, you know, and everyone's got to choose their own path as to how they do it.
I think we do test all our speakers with electronic dance music as well. And
Yes.
And it always sounds good.
Okay.
At whatever level.
Obviously,
Sorry, go on,
obviously
Derek.
a lot of modern music, it's more testing in terms of bass end. So that's fine in terms of stretching the loudspeaker to see what it's capable of, and that's absolutely fine.
Okay.
So, yeah.
Okay. I think that our time is going to go away, but one more question about for me, it was incredible the first time I saw it, this logic baffle of the HiFi. Could you tell us something about this?
Yeah, I mean, it's gone into in great detail in the BBC report, which is online, freely available. But fundamentally,
but
it's a very
I'm sorry,
it's
too much technical for average people. So
right,
it's somehow difficult to understand the technical
the maths
jargon.
loses me. Well, I think it's very simple. That the bigger a loudspeaker drive unit is, the more directional it is. You know, so all the slot does is, from the point of view of the air outside the speaker, it's making the drive unit look narrower.
Narrow, yeah.
So the 8-inch driver, which is the main thing it works on. So you've got an 8-inch diameter driver, or 200 centimeters, 20 centimeters, big bulb. And you've got a 10 centimeter slot in front of it. But so the dispersion, one of the things people say they make it wider, it's not making it wider that's the issue, it's making it more consistent off axis.
Okay.
And that's the point. And we've demonstrated quite clearly when we've listened to them that you can move off axis a lot more, and the stereo image holds consistency, it holds together much better. And that was the purpose of them.
But French is a design that is not widely adopted.
No, well, it doesn't look pretty, does it? That's the thing. I think, you got to be practical about these things. Why would you do that? I mean, that's a very old idea. It goes back to, I think, the 1930s originally. But no, it is an unusual thing. There are complications with it. I mean, most people wouldn't want to make a cabinet that's more complicated than it needs to be, and it is. Yeah. It is a complicating factor. But it does
I suppose that there are resonances between the behind the baffle and the front part of the cone.
Yeah. I mean, they come in at a certain frequency.
Okay.
The higher up you go, and so that the width of the slot, you can bring it down to a certain point, and then suddenly you'll start to get irregularities in response.
Okay.
And one of the things that the BBC in the report that they had some big variations just above the crossover frequency, and we found this was caused by the difference in distance between the cone and the plate because of cone position. Mm-hmm. So what we've done, which you can see if you physically see one, is we've thickened up the baffle just behind the slot. So we pushed the frequency of that up away from the crossover point.
Okay.
So that was a slight refinement to the original idea. But no, it does look counterintuitive, but it does work. One of the main things you've got to make sure of is that the cone movement doesn't hit the back of the slot, obviously. So, but of course, the mid-range unit, the 8-inch unit, crosses over at 400 hertz. So there is very little movement involved in normal music. So yeah, we've also applied that to the LS58. We've done another version of that because the LS58 originally had a slot. Mm-hmm. And I don't know why, when they did it out for production, they abandoned that, but they did. But we've produced one, and again, you move off axis, and the integrity of the sound stage is preserved to a great degree.
Okay. One last question: how do you listen to your music at home? With which type of system do you use?
Nothing very sophisticated is the answer to that. I've got Audiolab preamplifier and Audiolab monoblocks and Panasonic Pioneer CD player. That's
I suppose that it's exactly in front of you now.
Over there. Yeah. So I'm yes.
And with sources,
cables, we use very simple cables and things like that. Yeah.
And do you listen to CD or streaming audio or vinyl or what?
Mainly CD. Mainly CD. Yeah. I don't listen to vinyl at all, I must admit. I mean, we've never used it in design for the simple reason that it's too variable. There are too many variables. It's great for listening to. I don't have any problem with people using it as a source material. But when you look at all the different parameters in the reproduction of sort of cartridges and tracking weights and all that sort of stuff.
Yes.
As a loudspeaker designer, I don't want those parameters to interfere with things.
And what about you, Paul?
Myself, very simple. I've got a set of RLS6 floor standards, a Bryston amplifier, and which I run off a Lin 12. So mine is very simple as well. But I'd certainly like vinyl, but streaming is getting so good now. I mean, streaming going back 5 years ago, I wouldn't listen to it.
No,
but now with the advent of Tidal, etc., I think the results are just magnificent. I think they really are getting good. I don't listen to CDs anymore. It's either vinyl or just straight over to streaming.
Okay.
Again, you've got to listening between listening for pleasure and designing.
Very much
completely two different things.
Yes, it is.
Okay.
Yeah.
So thank you very much again for your time, and thank you.
Yeah, very nice to meet you, Giulio. Hope to see you in the near future.
Okay, bye-bye. See you.
Okay.
Bye.
Ciao.
Bye. Bye.